So you should have had enough time to go ahead and copy the notes, so let's go through them. So what are these inferences for regression? Basically, if you remember your least squares regression line, the y hat equals a plus bx, we can test the slope now, right? Because each time you take a different sample of the data, you might get a slightly different slope. So we can either make a confidence interval to estimate it, or we can run a hypothesis test just to test the slope. Okay, so let's talk about the confidence interval. The confidence interval uses your sample slope, B, to estimate the population slope beta, right? It gives you an interval of where you think that population slope is going to fall. So the steps are basically the same as the ones we've gone through before. You're going to check your conditions. It is a little different from the central limit theorem, so we'll talk about that next class, so don't worry about that today. Step 2, you're going to state your confidence level. That's the 90, 95, 99%, whatever you choose, whatever the problem states. And then you're going to name the interval. There's only one option here, so it's just going to be a t-interval for the slope. Then you're going to calculate the interval, right? So you take the slope you got from your sample, and then you have to go up or down a certain number of standard deviations. Now, how many standard deviations, right? So depending on your confidence level, you choose this, okay? And it's a T, so you're gonna have your degrees of freedom based on your sample size. And this whole time we've been doing n minus 1, well now it's n minus 2, because there's two things we don't know. We don't know the slope, and we don't know the y-intercept, right? We just have the estimates from our sample. So you're gonna have to subtract 2 from the sample size. So let me give you an example. So let's say we wanted to run a 95% confidence interval, right? So you come to your t-distribution table, you look at the 95% confidence level, and let's say we had a sample size of 30. So you're gonna come up to 30, but then you remember, oh yeah, my degrees of freedom are minus 2, so it's actually 28 degrees of freedom, and that's where you would get your critical value, right? How many standard deviations you need to go out to capture the 95% of the data. Okay, so that's where you get that number from your table. And then now you know how many standard deviations to go out. Well, how much is a standard deviation worth, right? So if you know your symbols, S is a standard deviation, B is your slope. So this is just a standard deviation of the slope. So where do you find that? And again, referencing those notes we had before, we said that this number right here was the standard deviation for the slope. Okay, so that's where you would get that number. And then when you subtract, you're going to get your lower end of your interval, and when you add, you're going to get your upper end. So now you have your interval, and then finally you're going to state your conclusion. So we are, however, confident that the slope is between blank and blank. And then of course you always want to have context in the problem, so you would say, on average, whatever your y is tends to increase or decrease depending on whether you got positive or negative values, somewhere between blank and blank for each x. And again, remember to write that in context. What is x? All right, and then there's one extra part for confidence intervals. So if you remember back to when we were doing two sample intervals, when we subtracted them and got 0, we said that, oh, that meant that there was no difference. So it's kind of the same thing here. What does the slope of 0 mean? So if you get 0 in that interval, it's basically saying that y is not changing as x increases. Okay, so if it falls in the interval, there's not enough evidence to suggest a linear relationship between x and y. And then if it does fall in the interval, there is enough evidence to suggest a linear relationship between x and y. Let's talk about the hypothesis test. So you're going to use the slope you got from your sample to test a hypothesis about the population slope. So to start, you got to write your hypotheses. So your null hypothesis that your population slope equals some value, and the alternative that it's less than, greater than, or not equal to that value. Step 2, you're going to check your conditions. And again, we'll talk about these next class, so don't worry about them today. Step 3, you're going to state your significance level. How often do you want to make a type 1 error? So 0.01, 0.05, whatever the problem gives you, or whatever you choose if it doesn't give you something. Okay, then you're going to name the test. There's only one option, so t-test for the slope. Once you do that, you're going to calculate your test statistic. How far away was your sample slope from the hypothesized slope? right? And then you're going to split that into standard deviations. Once you know how many standard deviations away your slope is from your hypothesized slope, you can figure out the probability of that happening if the null is true, right? Your p-value. So if you have a calculator, you would do a TCDF with the degrees of freedom, your sample size minus 2, again, because we don't know the slope and we don't know the y-intercept for the population, so you got to take away 2 from your sample size. And then it's going to ask you for a lower bound and an upper bound. So how do you choose that, right? So you have to go back and look at your alternative hypothesis, and if you had less than, you're going to go from negative infinity to whatever value you got on your test statistic. If you chose greater than up here for your alternative hypothesis, you're going to start with the test statistic value and then go to infinity. Okay, and then if it's not equal to, you do one of these two and you double it because it's two-tailed. Okay, very, very important. If you don't have a calculator, don't worry about it. You're probably not going to need it today on the Khan Academy. On Khan Academy, it will look like this guy here with your computer output. So you are already given your test statistic and p-value, right? So remember, here is your slope right here, right? Here is the standard deviation of the slope, and then they give you the test statistic. Okay, so no need to even calculate it, it's given to you, and then also your p-value. Now, the p-value that's given in these computer outputs is always two-tailed. So if they say the alternative hypothesis is less than, you're going to have to split this in half. I know this one's 0, so it doesn't really matter, but say you had like this guy up here, the 0.3, well, you're going to have to split it in half if you're running a one-tailed test, okay? All right, and then step 4 is just to state your conclusion. Same as before, if your p-value is less than your significance level, you're going to reject the null hypothesis and say that there is enough evidence to suggest the alternative hypothesis. And again, just remember to put this one in context. So you look back at your alternative hypothesis and you say, okay, well, the population slope is less than 0 or whatever it was. Okay, so make sure you write that out. Don't just write ha. All right, and then of course you guys can read this as well. Okay, so if the p-value is greater than alpha, you're going to fail to reject the null hypothesis. There's not enough evidence to suggest the alternative. Let's go over the problem. So your confidence interval, step 1, check your conditions. Again, we'll talk about this next class. Step 2, state your confidence level. So it didn't say anything here, so I just chose a 95%. Then you're going to name the interval, t-interval for the slope, and write your degrees of freedom. So where did I get this 100? Up here, your sample size, they took a sample of 100 students, so 100 minus 2, because again, we don't know the slope and we don't know the y-intercept. Then you're going to calculate your interval, so you start with your slope, what was the sample slope, this number right here, and then you go up and down a certain number of standard deviations. So you need to find this number in your table. So remember, we want 95% confidence level with 98 degrees of freedom. So if you look at your table, 95% confidence, and then we're looking for 98, which it doesn't have. It skips from 80 to 100. That's fine. Just go to the closest one and estimate. So about 1.984. That's where I got that number from. And then how much is a standard deviation worth? It tells you up here in the table, right? So just follow your slope, standard error for the slope right there. Then when you subtract, you should get this number. When you add, you should get this number. Okay, then your conclusion, we're 95% confident that on average, and then you need to figure out what is y in the problem. So if you come back up here, what are you trying to predict? The final exam score. Okay, so that's where I got that right there. That on average, the final exam scores tend to increase because both of these are positive. Somewhere between my two numbers there, 0.4708 and 1.0318 points for each, and then I'm supposed to put X. So what are we using to predict this final exam score? Their average quiz score. So for each additional point in their quiz average. Okay, and then finally the other part, what about 0? Does 0 fall in here? These are both positive, so no, 0 doesn't fall in there. And since it's not in the interval, there is enough evidence to suggest a linear relationship between quiz average and final exam scores. You can even add positive linear relationship in there if you want, because you can see that they're both positive. About the example for the hypothesis test. So you have your null and alternative hypothesis. The null is that the population slope is 0. Again, they didn't really give me anything. This is the general one, that it is 0. There isn't any really relationship, or that it's greater than. And I want to say greater than because if your quiz score goes up, is your final exam score going to go up? That's the relationship I chose. If you chose two-tailed or less than, you think it's backwards, that's fine. They didn't give you anything in this problem, so I just chose these two. All right, and then don't forget to define your variable. What is this population slope? Right, remember slope is change in y over change in x, so the true change in the y, the final exam score, for each x, your average quiz score, okay, for each average quiz average point. Okay, then you should check your conditions. Again, we'll talk about this next class. Step 3, state your significance level. It didn't give you anything, so I just chose the general 0.05. Name the test, a t-test for the slope. Calculate your test statistic. Now, this number is given to you right here, right? So I didn't really have to do this, but I just wanted to show you for the work, right? You take your sample slope, you subtract your hypothesized value, which again, it is usually 0, and then you split that into standard deviations. So each standard deviation is worth 0.14, 0.14. So your sample slope was 5.3 standard deviations away from the hypothesized slope. That's huge. That's really far away. That's why when you do this p-value, you end up with 0. So again, they give it to you up here, boom. But if you had to do it on your own in your calculator, since we said that the alternative was greater than 0, you would start with your test statistic as the lower bound, the 5.13 standard deviations, to a really big upper bound, 9999, and then put your degrees of freedom in there, which was the 98, okay? And then you would get this. And then again, just to go over again, because you'll see it on Khan Academy, if this is greater than this number they gave you here, you need to split it in half to figure out this p-value. Again, it doesn't really do anything here because it's 0. 0 split in half is still 0. But if it was a different number and you had an alternative hypothesis like this, you would need to divide this by 2, okay? So for the one-tailed test, they're always giving you a two-tailed test p-value here on the computer output. All right, and then your conclusion, since your p-value is less than your significance level, you're going to reject the null hypothesis. There is enough evidence to suggest a linear relationship between X and Y, right? Between the quiz average and the final exam scores. Make sure you give context. Awesome.